Cleanup meshes in 3D engines.
In 3D engine software programming, entities created within a scene are called meshes. Therefore, operations related to meshes become the soul of 3D software development. Thus, the importance of meshes cannot be overstated. Recently, during troubleshooting in our HiwayCAD project, we discovered that an old function for cleaning up meshes had suddenly stopped working. This function was written as follows, because this was an old function referenced in many places and had never reported an error. It wasn't suspected until after wasting 3 precious days. The story goes like this: after automatically deploying cabinets, when the interface was modified, it wasn't updated. However, when opening a cabinet door, it was visibly opening slowly, but there was another door inside. Opening that door again, this repeated 3 times before it fully opened. This meant that the mesh cleaning function wasn't working. The cabinets were being duplicated. Following this lead, we suspected this function. After consulting with the AI, I discovered the error was caused by the loop statement being placed inside a try-catch block. If a loop encounters an error, the system will break out of the closed loop chain and stop executing subsequent loops. The key is that deleting a single mesh will also delete its associated child meshes. Therefore, when the loop reaches a child mesh that no longer exists, an error will occur, causing it to exit the loop and end the function call. This is the essence of the error. So, it's simple. Just move the loop statement outside the try-catch block, and the error will be resolved. In 3D engines like Babylon.js, cleaning up meshes often triggers errors for the following reasons. 1. Link destruction of parent and child meshes. When a parent mesh is destroyed by calling single quotes.dispose, the engine automatically destroys all associated child meshes and removes them from the scene.meshes array. 2. Array index, null pointer issue. Submesh elements that have already been automatically destroyed may still be in the code's loop index. Accessing them will result in null, undefined values or throw an already disposed exception. Recommendation: add a non-null check and destruction status check before destruction. This is more robust than relying on try-catch blocks. In Babylon.js, manually calling mesh.dispose in a loop can easily lead to memory leaks or errors due to parent-child destruction linkage and residual resources materials, textures, skeletons, etc. For different levels of cleanup needs, the following are the best practices for memory cleanup in Babylon.js. 1. One-click destruction of the entire scene recommended for complete resets. If you need to switch levels or reload the entire scene, directly destroying the scene is the most efficient and cleanest way. Destroy all content in the scene mesh, light sources, camera, materials, textures, etc. Note: scene.dispose will release most of the GPU memory and CPU memory bound to the scene. 1. If you need to clear engine resources as well, you can call engine.dispose. 2. Precise batch cleanup of specific resource types. If you only want to clean up the mesh but keep the light sources and cameras, you can directly use Babylon.js single quotes s built-in scene resource array slicing cleanup method to avoid manual loop index out of bounds issues. Clean up all meshes without disrupting array iteration. Method A. Use slice to shallow copy the array to prevent dynamic modification of the original scene meshes array during dispose. Method B. Directly call Babylon's resource cleanup method if you only want to clear the mesh. Clean up and use materials and textures crucial for freeing up GPU memory. Destroying only the mesh does not automatically destroy the materials and textures it uses. To completely free up GPU memory, you need to clean up these useless resources. Destroy all textures and materials not referenced by any mesh. 3. Performance optimization techniques. In scenes where meshes are frequently created, destroyed such as bullets and particles in shooting games, frequent dispose will trigger a large amount of garbage collection GC overhead, causing stuttering. The optimization strategy is as follows. Prioritize the use of asset containers. If a part of the scene is loaded from a GLTF, OBJ model, asset containers can be used to achieve one-click loading and one-click unloading. Load and load into the container. Remove and destroy all resources mesh, material, texture, etc. from the scene with a single click. Use object pooling instead of frequent dispose. For frequently reused objects, do not destroy them. Simply hide or disable them. Hide and pause rendering. Re-enable them when needed. Freeze active mesh evaluation. temporarily freezing the scene's rendering evaluation before batch destroying. Creating a large number of meshes can significantly improve performance during batch cleanup. Prevent rendering evaluation. Perform batch dispose to resume evaluation.